Okay, this is IM1. This is lesson 5-4, exponential growth and decay. So one of the most applicable ways we can use exponential growth is talking about compound interest. That's almost always the interest you get paid at the bank. That's where they don't just pay you on the $100 you put in, but every month they increase it by a little bit based on the $100 plus the 1/4 that you made or whatever it is. This has a lot of variables in it, so it's something that you probably won't memorize this formula, and if I ever was to give you a test on it, I would give you this formula, right? It has a lot of variables. You just need to remember what they are. So A is the final balance. That's what we're solving for. P is the principal. That's the starting number. R is the annual interest. N is the number of times the interest is compounded a year. And T is in years. Notice that N is both there and there. All right, so let's try got it. Suppose when your friend was born, your friend's parents deposited $2,000. So the principal is going to be $2,000. It pays 4.5% compound interest monthly. What will the account balance be after 18 years? So the percentage is still the annual interest. The annual interest, which is R, that's still going to be 1.045. Right, that's it. It's compounded monthly, so the number of times the interest is compounded per year. So the N is going to be 12. And the 10 is number of years. Or sorry, T is number of years, so T is going to be 18. All right, so let's just set it up. At this point, it's just a plug and chug kind of equation. So 2,000 times 1 plus, this is represented as a decimal, so we actually don't need this written this way. We can write it 0.045. 0.045 divided by 12 to the power of 12 times 18. All right, let's do the inside portion of our fractions, let's do this portion first inside the parentheses. So we have 0.045 divided by 12 equals plus 1 equals this number. So we're going to have 2,000 times 1.0375, and we're going to raise that to the power 12 times 18. 12 times 18 equals 216. That's literally the number of times it's been, the number of times it'll be compounded. I think I missed a 0 there. So I'm going to do this math on the calculator just to give me a number that it's easy to remember. I'm going to do 4,5 divided by 12 equals plus 1 equals this number. I'm going to raise that to the power of 2. In fact, if you didn't want to do that, if you don't want to do any of the math, you could actually put it in 12 times 18. So you can put that in parentheses, 216. And then we're going to multiply that number by 2,000. And you couldn't see any of that. Sorry about that. And so our answer is going to be 4,489, and since it's money, we can take it to the 100th. So in 18 years, that's how much he would have increased.